In this video, we show how to find the equation of a line perpendicular to or parallel to a given line. This is a common question that is asked in the section having to do with lines. All right, suppose we're given this question here. We're given an equation of a line, and we're asked to find an equation of another line that is parallel to this given line and containing the point, say, -5, 3. Well, the first thing I would suggest in doing a problem like this is to understand the problem. Don't try to immediately solve the problem, but let's understand the problem. And then by understanding the problem, we're getting closer to the solution. All right, so to understand this problem, it says find the equation of a line parallel to the given line, but I don't see any given line. They give us an equation. So what we have to do is draw or plot the equation of this line, right? So that's what we'll do first, is sketch the graph of this line, of this equation. The quickest way probably to sketch the graph of an equation is by finding the intercepts. So let's go ahead and find the x and y intercepts. So for the x-intercept, we're going to let y be 0. When we let y be 0, we're going to have 2x equal to -4, so that x is equal to -2. So the x-intercept is -2, 0. And then let's go ahead and plot that point. Righty. And next, let's go ahead and find the y-intercept. Y-intercept is similar to finding the x-intercept, but here we're going to let x be 0 in the equation. For more information about this concept, it might be in a previous video. So when we let x equal 0 in our equation, we're going to have -3y equal -4. It's negative, which gives us that y is 4/3. Y-intercept is at 0, 4/3, which is a little bit over 1. So to plot that, of course, we can't get exactly correct based on our graph here. It's a little bit off. You know, in the scale here, the lines are not really that straight, but let's go ahead and approximate it the best we can. So that's 4/3, a little bit over 1. So let's say it's about right there. And just for added clarity, let's put the ordered pair next to it. And the ordered pair on this one, say it's -2, 0. All right, and then let's go ahead and draw a solid line through these points. Right. Okay, so this is the graph of the equation. 2x minus 3y equal -4. Right? So next, we want to find an equation of a line parallel to this line and containing the point -5, 3. So what we got to do, let's go ahead and plot the point -5, 3. -5 on the x and 3 on the y. That's about right about here. Right? Okay. -5, 3. And so we want an equation now of a line parallel to this given line and containing this point. So let's go ahead and imagine what line is parallel to this line. Parallel meaning never intersecting. The lines should never intersect each other. So I'm doing my best now to make a line parallel to the given line. Something like this here, right? Hope you can see this. All right. Now, our goal is, what is the equation of this line, right? What is the equation of this parallel line here? What's the equation of this line, right? And we know the equation of a line is typically given as y equal mx plus b. So we just need to find m and b for this parallel line. Now, in order to distinguish this line here from this parallel line, let's call our parallel line that we need y parallel. So we need y parallel, m parallel. We need this equation. So that is, we need m and we need b. All right, so here is what we understand about this problem. We need to find an equation of this parallel line to this given line and going through this point -5, 3. All right, so I hope the question is now clear. And in order to solve this problem, we need to know some rules, some other rules, which is that when two lines are parallel, their slopes are equal. Right? All righty, so now let's go ahead and solve this problem. All right, so first thing we need, so in order to solve this problem, again, we need the slope of that parallel line and we need the y-intercept of that parallel line. So, and we've got this fact here that when two lines are parallel, their slopes are equal. So the thing to do would be to rearrange the given equation so that the slope becomes very clear. So let's rearrange the equation and put it in this form, the slope-intercept form, and then that way the slope of that given equation will become very clear to us. And we know then that would be the same value as the slope for our needed equation. All right, so let's go ahead and rearrange our given equation. So we're going to have, so here, let's work out the solution. We've understood the problem. Let's solve that given equation to get y by itself. When we do that, we're going to have, let's see, we're going to have, I'm going to move the 2x over first. So 3y would would equal negative 2x minus 4. And then dividing both sides by negative 3, we're going to have y equal (2x over 3 minus or plus 4 over 3). All right, so we can see that our slope here, the slope here, m is equal to 2/3. And we know from parallel lines that the slopes for two lines that are parallel are equal. So we have here m parallel. So m parallel is 2/3, right? So we're halfway done in this problem. We found the slope of that line parallel to the given line. All right, next we need to, since we've got the slope and we've got a point, they gave us a point, negative 5, 3. A convenient way to solve the rest of this equation is to use the point slope formula. So let's go ahead and do that. So we have, using the point slope formula, it says y minus y1 equal m x minus x1. And x1 and y1 are the coordinates of this given point here, negative 5, 3. And we're going to use our slope here, 2/3. So substituting this in, we're going to have y minus y1, which was, back again, 3 2/3 x minus, I think that was a minus 3 or a minus 5. Which is going to give us a 2/3 x plus 5. So when I'm going to rewrite this because I'm running out of space a little bit. I'm going to move this stuff all the way up to here, right? And when we rearrange this, so we've got y minus 3 equal 2/3 x plus 10 over 3. See, I distributed here 2/3 times x and 2/3 times 5. And then we're going to add the 3 on both sides. So this will give us y equal 2/3 x plus 10 over 3 plus 3. Now, in order to add these two like terms here, I'm going to multiply top and bottom by 3. Top by 3, bottom by 3, that will make me have a common denominator so that I have y equal 2/3 x plus 9 over 3 plus 10, which would make us have 19 over 3. So here is our equation of a line that is parallel to the given line right here. All right, I hope you've seen how we find an equation of a line that is parallel to a given line. Let us go ahead and do a second example. This time we're given a similar statement, but we're trying to find the equation of a line perpendicular to a given line. So here's the equation we're given. And just to make things a little quicker, I've already graphed the equation of the given line. And I've shown here also this point here, negative 3, 6, is plotted. So we want the equation of this dotted line that is perpendicular to a given line. Now, perpendicular to means the lines intersect at right angles to each other. So right here, I'm going to make a box, do my best to make a box. This box here indicates that these lines intersect each other at right angles, right, or 90 degrees. So similar as before, we're going to need to know the slope of that perpendicular line, and we're going to need to know the y-intercept of that perpendicular line. So, and another fact we're going to need is that when two lines are perpendicular to each other, the product of their slopes is -1. All right? So hopefully we now understand the question very clearly, and let's go ahead and proceed to solve it. Right? So like before, I'm going to rearrange this equation that's given, and I'm going to put it in slope-intercept form. That is y equal mx plus b form. And then I'm going to recognize what the slope is. So let's do that first. Just make sure that is yes. Alrighty, so the slope here looks like it is -2/5. All right, and therefore we know that slope multiplied by the slope of a line that's perpendicular to that line is -1. So the question is, what must the slope be of the line perpendicular to that given line? In other words, what is M perpendicular? In order for us to have a product of -1, we see that M perpendicular must be 5/2. All right, now that we know what M perpendicular is, let's go ahead and finish this problem. So we know the slope and we know a point. Point is -3, -6. So since we know a point and the slope, we're going to go ahead and use our point slope form. That is y minus y1 equal mx minus x1. And then substitute what we know. Now we're using x1, y1 to be the coordinates for this point here. So x1 is -3, y1 is -6. So that y is equal to 5/2 plus 15/2 minus 6. Multiply top and bottom by 2 to make a common denominator. And it looks like when we add this, we're going to have 3/2. Plus 3/2. So here is our equation of a line that is perpendicular to that given line. Right? And let's make sure. So our y-intercept here was 3/2. That's a little bit over 1. That's about 1.5. And it is a little bit over 1 here, you can see. And our slope was positive. So we're just trying to confirm that everything is consistent, which it has to be in mathematics of numbers and symbols. I hope you found this video helpful. If so, like and subscribe. Catch you on the next one.